Hello everyone, I'm Kevin Larnier and I will present to you our main activities in our team in CS Group about the products and algorithm for the study of inland water bodies in support of the future AO missions. First, I'd like to introduce the context. The context is a SWOT mission, which is a collaboration between NASA, CNES, the Canadian Space Agency, UK Space Agency, and this mission will provide altimetric observation of water surface elevations with unprecedented precision and space-time resolution. And our main objectives here are to help CNES to develop numerous products and algorithms related to the monitoring of inland waters. The first activity is about radar simulation. The Radar Spy is a unified framework that gathers existing tools for simulating radar signals at L0 level. The main objective of this framework is modularity and performance. It can be extended for future AO missions, for instance. The main function of this framework is to simulate large scenes with unprecedented resolution. For instance, a simulation for the future WISA mission is 60 by 60 km at 1 meter resolution. It's about 190 gigabytes of data. So this framework needs efficient parallelizations and big data enforcement using DASC and NUMBA. Another very important activity in our group is about water detection. This activity is organized in two tasks. The first task has for objective to improve the water detection algorithm by improving the Markov random forest baseline method and using complementary data. So to do that, it uses combination of multiple sources through humus fusion, majority voting and fuzzy logic, and uses an ancillary database to circumvent non-observed areas such as dark water, etc. Apart from that, there is a development of a dedicated tool to assess the robustness of this water detection algorithm. The second task for water detection aims at thin river segmentation. Indeed, for thin rivers, there is a weak signal-to-noise ratio or dark water that often makes the Markov random forest baseline fail. So the aim of this study is to design a risk mitigation technique for water detection in radar studies. So it uses fusion of multi-temporal and multi-sources images, also ancillary data such as a priori river databases, and uses data fusion and optimization techniques. So this study will benefit SWOT but also future AO missions. To continue, I'd like to introduce two other activities that focus on the generation of level 2 products for inland water bodies. The first activity focuses on discharge algorithm. There are two objectives of this activity. First objective is to help research teams to design and implement the IVGI discharge algorithm and related tools. And the second objective is to prospect ancillary databases to improve priors and constraints for data assimilation of SWOT observation. So to do that, we helped the research team with the theoretical design, implementation and testing of this algorithm, the use of their multi-scales and multi-models, 0.5D, 1D and 2D hydraulic models, and to develop machine learning techniques to improve priors. So this algorithm has been tested on large database of studies from gauge basin to weakly gauge basins such as the Niger basin. And it's a joint work with other teams such as the GPL, the Ohio State University and the UMass for algorithm design and benchmarks. The second activity focuses on lake algorithm. The objective is to design and implement an algorithm that estimates variations of the volume of a lake between SWOT observation. So there are three main functions. The first one is an estimation of the observable lake bathymetry using a dam. Then a reconstruction of a lake polygon from SWOT pixel cloud is computed. And finally, the estimation of the variation of the volume is computed using two hypotheses. First, the linear hypothesis, and the second hypothesis is the quadratic hypothesis. The main goal of this activity is to provide hypsometric curves, which means the variation of the volume with respect to the water mass. To conclude, here at CS Group France, we have a consolidated team with 12 people, among them 4 are PhD, that works with an efficient synergy between different tasks such as prior databases, radar simulation, products and algorithm, and water detection. And we also have strong collaboration with universities and laboratories. The perspectives for our team is the future AO missions such as S3Top, JSON-CS, Roselle that could benefit from our expertise. And also, we aim at development of platforms for monitoring inland water bodies and water resource management. Here are some references about our work, and thank you very much for your attention.